Welcome back to another video on Critically Selected, a channel dedicated to providing you educational topics on anything and everything. We heavily rely on electricity in our daily lives, but rarely do we ever think about what it actually is. Today we will discuss the basics of electricity and hopefully gain an appreciation for this wonderful source of energy at our disposal. But before we begin, make sure to subscribe to our channel and comment down below on your favorite topic that you would like to see next on Critically Selected. To understand the basics of electricity, we must first understand the basics of the atom. Everything in the universe is made up of atoms. They are microscopic particles that make up all matter and are considered to be the building blocks of the universe. An atom is made up of even smaller particles called protons, electrons, and neutrons. Protons and electrons both carry an electrical charge, which is a force within the particles. Protons have a positive charge while electrons have a negative charge. The positive charge is usually represented by a plus sign and the negative charge is usually represented by a minus sign. Neutrons do not have any charge and are therefore considered neutral. Atoms have a center known as the nucleus, which is made up of protons and neutrons and is positively charged. The positively charged nucleus of the atom attracts and is circled by the negatively charged electrons. This is because opposite charges attract each other while negative charges repel one another. The positive charge of the proton is equal to the negative charge of the electron, despite an electron only being about 1/2000th the mass of a proton. When an atom is in balance, it has an equal number of protons and electrons. An atom becomes a negatively charged ion when it contains more electrons than protons, and a positively charged ion when it contains more protons than electrons. The neutrons carry no charge, and their numbers can vary. The number of protons in an atom determines the kind of atom or element it is. An element is a substance in which all of the atoms are identical. Atoms of one element all have the same number of protons but can have a different number of electrons and neutrons, in which case they are called isotopes. Electrons usually remain at a constant distance from the nucleus in precise shells. The shells closest to the nucleus can hold up to 2 electrons. The second shell can hold up to 8. The third shell up to 18, and the outer shells can hold even more. Some atoms with many protons can have as many as 7 shells with electrons in them. These shells are populated with electrons from the inside out. This means that any added electron will naturally fill in the innermost shells first before the outermost shell, which is called the valence shell. The valence shell contains valence electrons and determines the reactivity of the atom. When the valence shell is full, the atom is usually stable and less reactive. An example of this would be a hydrogen atom, which contains only 1 proton and 1 electron. The positive charge of the proton and the negative charge of the electron balance each other out, which causes the electron to be tightly held by the proton in the nucleus of a hydrogen atom. Since the hydrogen atom is balanced perfectly, the electron cannot move easily from its orbit. However, a copper atom contains 29 protons and 29 electrons, which orbit the nucleus of the atom. Since the first 28 electrons occupy the first 3 shells, we have 1 electron left for the 4th outermost shell of the copper atom. This is called a free electron or a valence electron that can be easily removed from the copper atom due to its distance from the nucleus. Similarly, a silver atom contains 47 electrons which occupy 5 shells with the first 46 electrons in the first 4 shells, leaving only 1 electron to occupy the 5th shell. The valence electron of the silver atom is further away from the center than the copper atom and is even easier to remove from its orbit since the force of attraction is not as strong there. Therefore, the structure of an atom determines how easily an electron can be removed. Valence electrons that can be easily removed from their orbit are very important to the study of electricity. Now that we know that applying a force can make electrons move from one atom to another, we conclude that electricity is nothing more than just the movement of electrons. Now that's some mind-blowing stuff. Most solids fall into one of the two broad categories based on their electrical properties. They are either conductors or insulators. When electrical current is applied to different materials such as metals or plastics, it may or may not flow freely. A material in which electrons can be moved easily from one atom to another is a good conductor because it conducts or is able to carry electricity. Metals like copper, silver, and aluminum are good conductors because they readily allow electrons to flow through them. In contrast, a material in which electrons are not able to move easily from their atoms is a poor conductor of electricity. These materials are called insulators because they are insulated against the flow of electrons. Examples of insulators are plastic, wood, paper, glass, and rubber. The properties of conductors and insulators are important because they have practical applications in home electrical systems and electrical devices and equipment. Metals like copper and aluminum are used in electrical wiring because they carry electrical current without any hindrances. Insulating materials like plastic and rubber are used as coatings on the outside of cables to prevent the current from leaking out. Static electricity occurs when there's a buildup of electrons. Electrons stay in one place and then jump to another object. Lightning is a form of static electricity because it simply is electrons moving from one cloud to another or jumping from a cloud to the ground. Similarly, when you rub your feet on a carpet and touch a metal doorknob, you experience a shock. This happens because the human body is a conductor while carpets are usually made out of materials that are good insulators. Thus, a charge imbalance is created when you lose electrons to the carpet and become positively charged. When you touch a metal object such as a doorknob, which is also a conductor with loosely held electrons in its outer orbits, you gain those electrons back in the form of a shock, restoring the electron imbalance. Although electrons can jump from time to time, they cannot move freely through the air to a positively charged atom. They need a medium through which they can move. When a source of energy like a battery is connected to a load such as a light bulb through a conductor, the electrons can move from the battery to the light bulb and back again. We call this a closed electric circuit. If an insulator such as plastic or rubber is placed somewhere in the circuit is open and the electrons cannot flow. A battery has two sides, one from which electrons are repelled and the other to which electrons are attracted. Since a conductor like a copper wire is attached to the two sides of the battery, electrons flow freely from one end to the other, creating an electric current. A current that always flows in one direction is called direct current or DC, and a current that flows back and forth is called an alternating current or AC. When we flip the light switch off, we open the circuit and no electricity flows to the light. When we turn a light switch on, electricity flows through a tiny wire in the bulb. The wire gets very hot and makes the gas in the bulb glow, giving us light. If, however, we have a low resistance conductor connected to a high voltage battery with a relatively smaller load, a high amount of current will flow and cause the wire to heat up and burn. The wire or the load, such as a light bulb, could also explode due to the large amount of electrical energy being dispersed in such a short amount of time. This situation is known as a short circuit and can be very dangerous and even life-threatening. Often there are many circuits in electrical devices that make it work. A TV set or a computer may have millions of parts that are connected in different ways, but that is a discussion for another time. So this was our take on the basics of electricity. We hope you enjoyed it. If you liked this video, make sure to give it a thumbs up and let us know your thoughts in the comments down below. Also subscribe to our channel if you want to see more content like this uploaded weekly. If you have any suggestions for future videos, let us know that too in the comment section. Until then, we'll see you in the next one.